introduction. Okay, so welcome everyone for the second session. So I hope everyone can see my screen. So I just want to, before starting the class, I just want to say that if I share you the script, first of all, you should do file, save a copy in your drive, because I am sharing the screen, so everyone will get the same copy. So if you edit that, like everyone can edit on that. So first of all, if you get the script, just save the copy in your Google Drive, so you can see one copy of the script came, and then you can edit on that script. Even for the assignment also, you should do the same thing. Just make a copy of the script and do editing on that. Because I checked the same script, everyone is kind of editing. Some people are editing. So it's better to save the script and name as your name or something. So this is just to give you an idea how to do this. Last class, we discussed about NumPy. Also one thing I wanted to let you know that last class we had an error when we checked the size of the NumPy array compared with the list. The problem was I couldn't figure it out in the class. So later I understood that. You remember like the introduction section we use for adding two numbers. You just give first number, second number, and here I was giving it as sum. Sum equals first plus second. So the thing is, sum is actually a built-in function in Python to do the summation. But in this case, I was defining sum as a variable, right? It will sum for first plus second. So in that case, it was showing error because in the checking the size. So this was what we studied last time. So we defined a list in Python. And I also defined an array. And then what we want to find is time required for to do each element square and sum. So you can see the sum is here. So this is like NumPy array. For NumPy it was fine, but for the Python, this sum it was showing error because we already defined this sum as first plus second variable. So that was the error last time happened. So if you do anything like don't give built-in functions as a variable, then it will create some error later in your code. So just want to show you that like if you see that for the NumPy array, if you want to do 400,000 like for numbers, if you want to find the square and the sum, it takes around 5.64 millisecond. But in the case of the list, it takes around 3.62 second. So you can see that NumPy is very efficient to do lot of calculations. So last time I couldn't show you this. The error was because of this. So make sure. So I think it's clear now. Okay, so we can just go back where we stopped. So we were basically looking at NumPy arrays, and last time I finished around this section. I thought there was some confusions. I think nobody has any doubt, right? Okay. Okay, I just keep checking on the chat box, like if some of you have doubts. Also, you can just talk, then it is easy for me to follow your doubts. Last time we had some doubts regarding, I hope like some of you may have some doubts regarding how to define one particular element. So I just modified the script and to represent you how you can find the index of a matrix. So if you're considering this as a matrix, so the index starts from 0, 1, 2, 3. So these are the column indices and these are the row indices. So for example, if you consider the element G, so the index is 1, 1. So first you specify with the row, then you specify with the column. So for example, if you see for the letter N, so the indices for this is 2, 3. First you talk about the row index, then you talk about the column index. So this is how you can get the index. So for example, I can just show from here. So you can see this is a NumPy array. It's like a 5 cross 5 array, 5 rows, 5 columns. So if you see this, we are particularly taking one section of a this matrix. So I mentioned that if you separate this by a comma, that means first section is only for row and this section is for column. So you can see from this, from last class, we learned that if you have a dot, that means you have to consider all rows till this is final row. So till third index. So that means 0, 1, 2, 3. So you have all row till here, but the column is from 2 till end. So that means the column is 0, 1, 2. So 2 till end. So the elements will be from 35, 40, 52, 13, 14, 15, and 33, 34, and 35. So if you run this, you can see you can see it's a shape of this matrix is 5, 5. That means 5 rows, 5 column. And you can see that we have taken a particular section of this matrix based on this index. So now I think it is clear for you. So if you have any doubt, let me know. So similarly, you can try, like I send you the script, so you can try for what about like 3, like you start from the index 3 till end. That means 0, 1, 2, 3. So all the rows here, and you see this is means all columns. So you will get last 2 rows. You'll get last 2 rows. So similarly, you can do the rest. And another thing, like this is like, if you see, may be confusing because you have now 3 kind of sections. So for example, I define a matrix X. I define an array np.a range. So that means the array have 28 elements. So last time we learned this, we reshape into 4, 7. That means 4 rows and 7 columns. So if we visualize this, it's like 4 rows and 7 column, and you can have the elements from 0 till 27. That is total 28 elements. So if you see this, this means start index, end row index, and index have a step size of 2. So that means we have we are starting, we have to consider all rows. Like this dot means you have to consider all rows, but the step size of 2, that means consider this 0th row, then don't include this row because step size is 2. That means 0, then you have to consider this row. Similarly, for the column, you have to consider all column, but the step size is 3. That means you consider first this column, 0, 7, 14, 21. Then don't include this. This, you have to go for this because this is 0, 1, 2, 3. Then you have to go to this column. Then you have to go to the, yes, yes.
Your screen is not visible in a large window. It's just visible in a small window. Can you please just maximize it? I don't know if this problem is for everyone or only for me.
Is it visible or maybe it's
Okay, it's now okay.
Yeah, thank you.
now it's okay?
Yes.
Thank you.
Yes.
Okay. Sorry. Thanks for letting me know. Yeah, so we are defining this array now. There's like 4 rows and 7 column. And what we are discussing is like, so this is like, we have to consider all rows with a step index 2. So we are considering this row and this row. For the columns, we have to consider all column, but the step size is 3. That means considering this column, then we have to consider this column and the last column. So if you run this, you can see it's like 0, 14, 3, 17, and 620. Yeah, so I think it's fine now. You can also work for this. This is means all rows, and this is all column, but like with the step size of 3. So it will be now like this. You can see all rows is there, but column is like the same as this condition. So we have from 0, 3, and 6. Also, you can change an element in an this kind of array. For that, I define another array called A. So you can see that it is like 2 rows and 1, 2, 3, 5 column. And if I select A of 1, 2, so you may now familiar what is A of 1, 2 means. First row, and the second column. So 0, 1, 2. So that means we are considering this element. So you change this element as 10. So now you modified your matrix A, and you can see that the 8 is replaced by now 10. So if you have a matrix, so you can now change the elements by, you can specify the index of the elements and give whatever number you want. So this is like you can change a particular change the element in a particular column. That means all rows and the column is 4. You change it into 0. So now you can understand that. So you have to consider all row and you have to consider the fourth column. That means 0, 1, 2, 3, 4. So that means all the elements in the fourth column is 0 now. So similarly, I'm defining another array. In this, you can see that it is not like the similar way of array, right? You can see like 2 sub rows here. So in this case, if you want to find an index, so you have to have 3 indexes. The first one will be choosing which of the sub rows. So I can say that this is one row, I can say these are sub rows of these arrays. So the first element is going for choosing which of the sub array you want, and then second one is the row and third one is the column. So if you see for this C, 0 means you're considering the first sub row, and then 1 means you're considering even in this sub row, you're considering this row, because 0th row, 1 row. And then 2 means you're considering the second column. So the C of this means you are considering the element 6. So if you find something like that, that means the array is like this. And if you have 3 indices, A, B, C, that means if you have some sub array like that. And if you see the shape of this array, it is like 2, 2, 3. That means it has 2 sub rows, and each sub row has 2 rows and 3 columns. And then next session is like concatenate arrays. That means if you have 2, 3 arrays, you can merge all these arrays together and to create a big array. So if you see, I defined 3 arrays. So that means this is an array with the 2 elements, 11 and 12. Then another array, and so I defined 3 arrays. And if you concatenate these 3, you can see everything in one array. So 11, 12, that elements, and then you added 18, 7, 6, and then you add 1, 3, 5. Then like for concatenating 1D array, you can have different shapes like 2, 3, 5, whatever. But this is an example I'm showing for different arrays in a different matrix form. In that case, if you want to concatenate, you want the arrays to be in the same shape. So first I create x is equal to nb.a range of 24. So that is an array with 24 elements, and then reshaping that into 4, 3, 2. Now you understood what is 4, 3, 2, right? 4 means you're splitting into 4 subsection, and then each section there is 3 row and they have 2 columns. So let's visualize how is the x. If I see what is x, so now you can see it has like 23 elements, and it is split into 1, 2, 3, 4 subsection, and each subsection it has like 3 rows and 2 columns. Similarly, y is also from 100 to 124. You have to also reshape that into the same shape. Then if you concatenate both of them, you can now see, right? Like from 23 till 23, you have x, and then from 100 to 123, you have y. So you concatenate both x and y. So it's clear? It's fine?
Yes, it's clear.
Okay. The another thing you can do with these NumPy arrays is you can initialize the matrices and arrays. That means if you have np.zeros of 5, that means you create an array of 5 elements. This 5 means the size of that 5 elements with the value 0, because you are giving np.zeros. So if you see this, so it's like a 1D array. You can also change this into different shape, like np.0. np dot 0 of 2 comma 3, that means 2 rows and 3 columns. You can see that this is like 2 rows and 3 columns. You can initialize that. And similarly, you can also do not only 0, you can make it as 1 arrays with. So this is like all the arrays with all 1 element with 4 subsections and each section 2 rows and 2 columns. So what you have to do is you have to get familiarized with how the rows and columns are defined in this way. Then like you can do the initialization. Maybe you want to initialize with a particular value, not only 0 or 1. In that case, you can do like np.full 2 cross 2 comma 2 comma 99. That means you are creating a 2 cross 2 matrix with the value 99. So np.full means all values will be 99. If you want to change this to some other, let's say like 10, you can change that number into 10. Also, you can modify this, like I will change it into 5 rows, 2 columns. So you can see you have an array with 5 rows and 2 columns with a particular number 10. So these are kind of an easy way to create something like one particular number or something. Also, you can create some identity matrix. So that 4 means it's an identity matrix, so it's a square matrix. So it is like 4 rows and 4 columns. So if you have like here 10 or something, you're creating an identity. So identity matrix means all the diagonal elements are 1. So the size is 10. That means you have a 10 cross 10 matrix. So other important thing is I mentioned for the list, it's difficult to do multiplication, addition of 2 lists and all. But for the number arrays, it's very easy to do. So we have an array A. You can just do A plus 2. That means the 2 gets added with every element of the array. So if you see this is 1, 2, 3, 4. So you're adding like 2 with every element. So it is 3, 4, 5, 6. Similarly, you can do multiplication. So each of the elements get multiplied by 2. So it will be 2, 4, 6 and 8. And also you can do division. So whatever like mathematical operation you want to perform, you can do it this. For example, I'm giving sine of A. That means you're taking sine value of each of the elements. So it is an array like this. Another thing you can do is like statistics. Statistics means like if you have an array or matrix or whatever, you can do the mean of that. You can do standard deviation. What is the sum of the elements of the array? So in that case, I'm defining now an array like this, 1, 2, 3, 4, 5, 6. So if you see np dot minimum of stats, that means we are finding the minimum value of this array. And there is np dot max, that means maximum value of the array. So you can see the minimum is 1 and maximum is 6. So these are useful if you have a large value of like if you have maybe like 1000 cross 1000 matrix or something, very random number. So if you want, it's very difficult for you to go through each of the rows and columns to see. So you can just use this np.minimum to find the minimum value and maximum. Another thing you can do is the sum of the elements in each row, or you can do each column. So for that, you have to do np.minimum, the stat, that is our matrix. So you have to understand that axis equal to 1 means you're going for row. Axis equal to 0 means going for 0. Only 2 axis values. Axis 1 are the elements in the row wise, and 0 is column wise. If you see for np.minimum of axis 1, it will go for what is the minimum value of this row, what is the minimum value of this row. So if you check this, you can see that first one is for the minimum value, right? So for this row, minimum value is 1, and for this row, minimum value is 4. So next one is maximum. So for this row, maximum value is 3, and for this row, maximum value is 6. So you can get that. If you want to find for the column wise, you can just go to 0 and you can get the minimum value and maximum value across these columns. Also, you can find the sum of the elements. You can just do np.sum. So the sum of these all elements is 21. This is, you can do the sum. Similarly, you can do the sum for each row and each column. So if you see the sum of this row is basically 6, and this row is 15, and this is sum with each of the column. 4 plus 1 is 5, 5 plus 2 7, and 6 plus 3 9. So just remember about x is equal to 1 for row and x is equal to 0 for column. You can do sum, minimum, maximum, all these kind of things. So another important thing is the conditional operation. That's what I was telling you. This is kind of very important. Like if you want to filter some of the information from your data, you can do conditional operation, or you can say Boolean indexing. So first of all, if I create np.full 3,35, this means I have a 3 row, 3 column with all elements as like 5. So this is this. And if I'm creating a Boolean array, so what I'm doing is D type is bool and it is true. That means basically Boolean indexing. So these have two values, basically true and false. So you can also create in false like this. But if you see whatever D type of bool, it has two values, only true and false. So because we are creating here an array with numbers, but in bool, like you have like true or false. So if you create np.full 9 and reshape into 3 cross 3, that you have like 3 and 3 row and 3 column, and you have like it's given true as the Boolean type. So it is like giving all elements with the true, because it doesn't have any values, only true or false. So whatever, it will show either true or false. So now we can give some conditions and see how the Boolean this is working. So if you have an array now 4 7 3 4 2 8. So if you print a equals 4, that means you want to print whatever in the array having the value 4. So if you print this, you are getting the output as like this. So it's a Boolean condition. You can see true from 1 and this indices. So that means 4 is at first, right? Like they want everything condition to be a equals 4. So wherever the 4 is there, that value is satisfied. So that will give you true value. So you can see true here as well as in this index. So like this, you can get whether some condition is there. From this, you can also find the length of this condition, and you can get how many values there like satisfying this condition. It will be more clear if I show you some example like this. If you have an array like this, and if you have like a greater than 14, that means the matrix, whatever I wanted to find, whatever values which is greater than 14. So if I print this, you can see some true, false, and you can see the true. So that means this value is greater than 14. So if you see from this matrix, like you can see it is like 50. So it's greater than 14. Another one is here, true. That means it is 20. It's greater than 14. So similarly, you can find all the elements. So it's easy way is this is the condition B, right? B is A greater than 14. You can assign this condition into the full array. That means A of B. Now the condition is imposed into this array and you defined it as new array C. So now you want to find, or maybe I can just print what is C. And I'm finding the length of C also. So now what we are getting is we define the condition, and you can see it is a new array, and you can see this means whatever values which is greater than 14. You can see 20, 50, 15. So these are the numbers in these arrays which is greater than 14, and you can see that from the length of that array you can see how many elements, 5, because it's difficult for you to just count, right, how many true is there. So it's always good to make that condition into your original array, and you can find the length of that. Then you will get that how many elements are greater than particular value. Is this clear? Okay. So I just showed some of examples. So I'm not going through every one of the example. You can try, because we don't have that, because I have to cover some more things today. So similarly, maybe one more example I can show you. So this is like AB. This is an array of 1, 2, 3, 4. And I'm defining it as AB of true, true, false, false. And also there is another condition, AB greater than or equal to 2 and AB of AB greater than or equal to 2. So if you see this, the first one is like you can see I defined a true, true, false, false. That means from this AB array, I want only the true value, because if you have true, true, false, false, then you means when you print it out, it will give the true values. That means only 1, 2, because we assigned 1 and 2 are true values. And another one is like AB greater than or equal to 3. So that is, you can see 3 and 4. So if you're printing out, it's coming into a Boolean way. So it's false, false, true, true, because the condition is true for 3 greater than AB greater than or equal to 3. That is like 3 and 4. And here you can see that the condition AB greater than or equal to 2 is imposed into AB. So that means when you print it out, I mean, like you can just get 2, 3, 4. If you didn't impose this condition into AB, you will get true, false, true, false. So that's why I'm just putting this condition into the actual array. Similarly, you can have like multiple operations, like you can see AB of, the condition is AB greater than or equal to 2 and AB is divisible by 2, completely divisible by 2. So if these two conditions are satisfied, so what will be the AB then now? You can see that 1, 2, 3, 4, like AB greater than or equal to 2 is basically 2, 3, 4, but completely divisible by 2 is only 2 elements, 2 and 4. So you get this array. Similarly, you can have like some OR condition, like that means AB equal 1 or AB equal to. Either of the condition true, you can like get the value. So you can define lot of condition, whatever condition you want, you can use AND or you can choose one particular element. So this is one of the advantage of this Boolean condition. You can filter out the values. Then you can also do sum, like AB.sum and AB.mean. You may familiar like dot sum, dot mean, to find the sum of the elements, mean of the elements. And you can also do some standard deviation, variance, and all. Another thing is like this is kind of way of also define some arrays using random metrics, random values. So if you want to create a 1D array contains like 5 random floats, basically rand function is like from create a random numbers from 0 to 1. So if you specify the 5, that means the size of the random array. So if you print A, you can see it's like a 1D array contains like a random floats. It's like from 0 to 1 actually. If you want integers, you have to define rand int and a 10. So the 10 is like you have the values from 0 to 10 and the size is 5. That means you're creating a random array with 5 is the size and the numbers is from 0 to 10. You can see this is. So similarly, C also, like C is like it's a random integer, like within from 0 to 100. The size is 3 cross 3. That means 3 row, 3 column containing random integers from 0 to 100. So you can see it's from like this. And I'm imposing a condition C greater than 30. So I want the elements which is greater than 30. So if I do like this, I'm getting like true, false. So it's better to if you want to find how many numbers is greater than 30, you can put this condition into your actual array and you can print out the length of it. So you can easily see that from this matrix, like 7 elements is greater than 30. So that is this indexing, Boolean indexing. Then there is like you can do some matrix operations. You can create a matrix, random matrix. You can see that this is like from 0 to 30 and the size is 3 cross 3. And you can do transpose of the matrix. So transpose means rows and columns are interchanged. And you can define 2 matrices and you can do the multiplication, dot product, and all kind of operations. So these are kind of some other applications. And maybe I don't show this exactly. I can just tell you how to go for that. And then I have to maybe go for the other section. So this section is showing you can load a data from a file. So I mentioned that I have sent you two data files. One is a data.txt and another one is like a shopping data. So this is a txt file. So you can see that it is like a file like this. You can see it as like 3 rows kind of thing. So I uploaded the data into my Google Drive, and you can see that if you want to load that data, you have to go, because now this current working directory, I mean, my module is in my drive, and everything is here. So if I want to get this data, I want to actually this is in the same directory, but if you are checking in a different directory, you have to change the path. So for that you have to do import OS and os.change directory. You can see it's content drive, my drive, and collab notebook. So you can see that this is my drive, collab notebook. So this is the path. Actually, my data is there. So I can change the directory, and I can load the data. So the data name is data.txt. So the delimiter is basically commas. So because you see the data contains like separating by commas, so you have to just specify like this. And if you print this data, you can see like in 3 kind of rows, because in the data is also like that. But if you notice, it's kind of coming out to be float, right? So the data is like, kind of integer value, but when you load in this, it coming out to be some float values. So you can change that by as type int32. So this is like you're converting into an integer. So you can specify whether you want int32 or int64. So if it is int32, the size is little bit less. So you can convert it into an integer then. So you will get an array, right? So then you can do a lot of the operations that I explained before, the Boolean indexing. If file date is greater than 50, that means you want the elements which is greater than 50. So that condition is imposed into this file data, and I named it as a new file. So, and then I can find the length of the file. So you can see that these are the numbers which is greater than 50. So I have like 9 numbers which is greater than 50. Okay. Oh, sorry. Okay, I think it's fine. You can see the screen, right?
Yeah, your screen is
okay.
visible.
Okay.
So, sorry, could you please give some more details about the OS module, like what kind of module it is for NumPy?
Okay. So, so the OS, like if OS is kind of a system module, like if you want to do some directory, because if you have some lot of datas, so some kind of if you have lot of datas, and you see, I just put all datas into one folder or something, and you can access this from a different, if you have a different folder or something, you can access the files in this folder by specifying the path. Path means where our data is stored. So, so in all the Python and everywhere, if you want to access the data, you have to change your directory. I mean, like where your data is. So for that purpose, I am just giving import OS, because you need that OS module for this os.change directory, and this is the path where my data is stored. So it is in my drive, collab notebook.
Okay, got it.
This is
So,
my drive.
your assignment, I think, yeah, like, okay, at all we can say that totally we have 4 ways in order to upload our, like our data frame for NumPy, or either or NumPy or pandas. For example, we have CSV files or Excel sheet.
Yeah. So you have to specify which of that file. So it's .txt, because it's the name is data.txt.
Okay.
So you have to give the same way. The only thing you have to notice is, otherwise, like if you didn't specify the path, maybe they said, okay, there is no file exist because it cannot see where it is. So you have to specify where it's. Now it's in Colab notebook. If you see, it is in the Colab notebook. You see, in that folder, the data is there.
Okay, okay. Thank you so much.
Yeah, so now we are in that, and I loaded the data. So the name is data.txt. If you're loading the file, you have to give this inverted comma. And then you can see that you get the file and you impose some conditions, and you can also check if any of the column is greater than 50. So 18 column. Okay, so maybe this is wrong I have. Or maybe if we have 18 columns, okay. So checking if any of the column is greater than 50. So you see that axis is 0 means we are checking like this. And that means np.any file data greater than 50. That means if you're checking every column, is any of this column has any number which is greater than 50. So if you see, it will give a 1D array. So that means how to read means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So you have 18 columns, right? So you have like 18 values here. And you can see that 131 is first column, right? In this column, there is no element which is greater than 50. That's why it's false. And if you notice like this column, this is also false, this is false. But if you go for this column 19676, so you can see it's true. That means here all values is greater than 50. So this is like one condition. And similarly, you can go for checking the row. If you go for every row, if you have this condition is satisfied, you can see it's if it is row wise, you will get only 3 values, right? Because you're checking any of these elements is greater than 50. So you can see there is value greater than 50. So it's true. This is also true. This is also true. So it's like that. And also you have multiple conditions, like if you want the file data which is greater than 50 and the numbers which is less than 100. So if you see, you have like 6 numbers which is greater than 50 as well as like less than 100. If you see, you can also load these data and you can try different conditions. Maybe you can see that how many numbers is divisible by 2. You can create that condition and see how many data is divisible. Or you can see that how many numbers is like, greater than 766 and less than 1000, something like that. So you can define various conditions and find how this is useful for you to easily get the information. So that is, I just want to give your overall ideas NumPy. Maybe now you are convinced that you can do lot of things very easily using NumPy module. Just you have to do np dot if you want sum dot sum, and you can do lot of other stuffs, Boolean indexing, filtering, everything using NumPy arrays. Also one thing is like the metrics, how to filter the elements in the metrics and all. So it's all easy through this NumPy. And so is it fine till now? Okay. So now I will go for the pandas. So this is kind of an important section. So in this section, I will show you the power of how to, read the data, and you can manipulate the data, large like data set. So this is to do this, you have to first install pandas. So if you're working in a Google Colab, you have to do this pip install pandas. But if you're working with a Jupyter Notebook, Spider, and all these kind of things, it's already inbuilt. So you don't have to do this, but you have to load the library, because now pandas is installed here. So you have to import that pandas as PD. So from now onwards, whatever, if you want to use pandas, you can just define PD dot. So now we import the library. And you have to see that there are 2 important data structures in pandas. One is series and data frame. So basically, series is a one-dimensional array-like object, but it contains 2 sections. So if you consider for a list, if you create a list, it is 0, 1, 2, 3, 4. But we know that the indexes is 0, 1, 2 like that, each element. But in this Panda series, it already gives one array with indices and the array next array with the values. So let's see here. So we are defining a Panda series. For that you have to do pd.series, and you have a kind of this curved bracket, and you have to define that in a square bracket like this. So if you print this, what you are seeing is, you can see 0, 1, 2, 3, 5, because this index is automatically comes and this is our values. But if you see NumPy arrays and all, you will only get these values as 1D array. But in Pandas, like you will get with indices and with the numbers. So this is the default index 0 to 5, but maybe, maybe you can check the data type index values of this Panda series. Just do s.d type. This is also similar to NumPy. If you think if you want to NumPy array also, you can .d type. So you can see that int 64, that means all these are integers and all are stored in 64-bit. And if you see s.index, and you can see that the index give the range of the index. You can see the range index starts from 0, end at 6. Lot of things like the upper limit is not included. So that means the value 6 is not included, but it from 0 to 5 basically. Step size is 1. And if you s.values, that means you can get the elements of the series. So these are the elements of the series. Similarly, you can get each element of the series by just using a square bracket, like s of 0, that means first element, s of 1, that means second element. You see 20 and 35, you can get like this. The other thing is, initially you have seen it is a default index, right? 0, 1, 2, 5. You can define your own index. So you can do it by s.index, and you can give a list. So I just give a list of some people name. And if I print now, you can see that 0 to 5 becomes now Alice, Bob, Charlie, Mary. So you can change the indexes as the index you want. The another way of creating the series with indexes is, you can just define with a dictionary. So you may familiar with dictionary. That means you can have kind of some strings and you can define the values. So if I define some people name and some quantities I define, and I have to create a Panda series. For that I have to do pd.series of this quantity. So now if you run this, you can see that you get the same thing as like the name and the values. Also, you can define in a list way. That means you create fruits, some list of fruits and some quantities. So you can see that quantities is also another list. And then you can define pd.series quantities, comma, the index is equal to fruits, because you want to specify what is your index. So that you want the index has to be this. So you just specify index as fruits, and you just given the name as fruits. So you will get it like this now. Mangoes, orange, cherries, and grapes, and the values like this. Similarly, you can just get the each element of the this Panda series, like s of 0 means first element. Also, you can now specify with s of this index. So now you have to think that this is an index. This is a basically string now, because it is mangoes. It's not a number like 0, 1, 2, 3. So you have to put this in inverted comma. So you can see you can get the particular element. Also, you can like use ilog. There is a function called ilog. This is also used to specify particular row. So if you do s.ilog of 0, that means you will get the first index. So these are different kind of terminology to define the same thing. So I just want to familiarize you with these different terminologies. Then if you want more, like we can choose how many elements we need from the original series, because original series, if you see, it's like 4 values, right? But you need only mangoes and cherries. So you can just take s of mangoes, comma, cherries, and you will get the data of that only. Similarly, instead of these mangoes and cherries, you can just give 0 and 2 because these are the index of mangoes and cherries. If you see 0 and 2, you can get the same thing. So basically, you can maybe try with other s.log. This is also another method to get the elements. The other thing is like if you see, you may now understood what is mangoes dot grapes. That means you have to start from mangoes till grapes. You need all the elements from mangoes till grapes. So in the pandas, like the upper limit is included. Some cases we see that the upper limit is not included, but in this case you can say the upper limit is included. For example, I just given in the list case. In the list case, it is ABC, and if you take all elements up to 2, the second index is not included. It's only you will get A and B. But in this pandas, you will get the upper limit is also included. Similarly, you can use the advantage of this Boolean arrays. So if you say S is greater than 20, so you will get whatever the values which is greater than 20. So you can see the output will be true, false, right? So the S is basically 20, 33 like this one. And if you see S is greater than 20 and you can get it like true or false. Because greater than 20 is basically this orange cherries. So both these values is true, others are false. Also, you can do math operations. You can do S into 2. That means all these elements get multiplied by 2. So similarly, you can do the Boolean values like different conditions. You can try that also. Also, you can change the values. S of mangoes is 50. So you can see earlier S of the mangoes is basically 40, the value. Now we changed it into 50. And if you print S now, you see the mangoes values is changed. So it's kind of, if once you used to it, it's easy to find how to change the values. But if you don't remember all these things, like I also don't remember all the things, like you can always like go to Google and check how to, change the values, and also you can easily figure it out. This one, maybe maybe someone can maybe answer me what it is this. Like the condition is S is greater than 30 equals 66 and S of this. So what should be the answer of this? Can anyone tell me? Just to know that whether you understood it. So this means like for the S is this kind of our data frame. And if it is greater than 30, is changed into 66. And this condition is imposed into S. That means whatever the value is greater than 30 should be changed by 66. So if you see the answer, I hope you will understand it. You can see the 50, this is greater than 30, so that changed to 66, and orange is already 66, it's there, and the cherry is also changed it into 66. So this is the Boolean that conditioning. So another useful property is like if you have some data and there is a missing value, you want to understand where is the missing value and how you can replace the missing value. For that, I have shown an example here. So it's kind of a visitors, and I defined it in a dictionary form, kind of January different month, and I'm giving some different visitors. And you can define the series like pd.series of the visitors is this one, and you can get this data as different month and the visitors. So now I defined another list of month, January, February, June, November, August. And I am creating a series, pd.series. And you can see this contains the data of visitors. Visitors means this data, and my index is month. That means I am defining the index as this. So if I run this, you could see that I could see some NaN values. Why this is happened? Because if you see this month, there is no month kind of June and August, and I defined this in a different month, and there is no data for the June and August. That's why it is showing none. None means not a number. So this is kind of a missing number. So if you want to see what are, like if you have a data, what are the missing numbers, you can just dot use that is null. Null means nothing, right? The value meaning. So you wanted to know the visitor series, dot is null. So if you do that, it's basically giving the Boolean type. You can see the type is bool, right? If you have something like true, false is coming, it's like Boolean type. So you can see that is null means true. That means June is null value. August is also null value because these two are true. In another way, you can do not null. So if you want to see whatever the values which is not null, means which is actual values. So you can see that these are like not null and the null values are like June and August. You can just drop if you want to drop because you have null values, so you don't want that in your data. You can remove that using drop NA. That means you are dropping the null values. So if you do that, you can see now that you can see the June and August is removed from this data. The another thing you can do is maybe sometimes you don't want to remove, you want to add some values into that null section. For that, you can use fill NA function. So if you dot fill NA of 0, this means you're filling the NaN value with 0. So if you see the June and August is now 0. It was NaN actually, but now you replace it with 0. You can also replace it with the actual values because if you see these are some visitor values, so you can also give some large numbers there. So for that, you can just define missing month is like kind of a dictionary form. I just define June as this number, August as this number. And then you can give visitor.series fill NA. Earlier it was 0, right? Now we are giving that values as missing months. So it goes to here. So missing month is like this. Then now, if you run this, you can get this actual value. The June and August is filled with the values. But one thing you can notice now, it is like in a float. So if you want to convert into integer, you have to just do .as type integer. Now the float is converted into integer. Okay, so that is kind of a series. And then like the data frame. So the data frame is like you have like multiple series together. So it is same as like kind of a spreadsheet, Excel, CSV kind of data. To give an example, so I'm defining some range like 2010 to 2014, and I have two series. And if I do that concatenating these three series, and you can see with the index years, so what I'm getting is, you see here like each of these are concatenating with this axis. Axis like, I mean axis 0. That means column wise. So you have one data shop 1, the next data is going into down and another is going into here 2010 to 2013 and again 2010 to 2013. But you want in row wise. So in that case, what you have to do, you have to put axis is equal to 1. Then you can get the data like this. So this is basically a data frame. You have 2-3 series together with the same index. You can change the name of these because now it is 0, 1, 2. You want to change the name of the column. So for that, you can do dot column like shops. Shops is the name, like you have to do shops df dot columns is equal to because your this new value like data frame is shop df, and if you want to change the column, you have to do dot columns is equal to shop. So it will go for ABC now. So it's changed at ABC. An alternate way to give the column names, you can do just shop1 dot name, shop2 dot name. If you do like that, you can just change the name like this. So these are different way of changing the column name. So if I just check what is the type of this shop DF, and you can see it is a data frame. That means you can concatenate like 2-3 series to create a data frame. So you can also create data frame from dictionary. So you can have like a the population. Earlier we defined population and one value, but here like if you want to create a data frame, you have to do population and you have a list of numbers. Surface area, it's another list, and continent is another list. So you define places, and if you want to create the data frame, pd.dataframe places. So you can get the kind of a data frame here. Then you can, if you want to see the values of the column names, you can just do dot columns dot values. So if you do that, you can get the column names, its population, surface area, and continent. Then next one, like if you want to change the index values, like it's like given 0, 1, 2, 3, you can change it into a particular value. So I just define a new list of country like this, and I change, you can pd.dataframe, places is our value, places is our this data frame value, comma, index. I'm giving the index as country. So now if I run this, you can see that 0, 1, 2, 3 is changed by these indices because you defined that as country now. You can also give the index in another way. You can do dot index, and this is another way to easy way to create the index. Okay, yeah, we came this. Also, you can do rearrange the order of the columns. So for that, you have to define the data frame places, and the columns you can just shuffle the names. Here it was population, surface area, continent, but now I just want continent to be first. So continent, then population to be second, and surface area to be third. So I can just give like this. Yeah, so you can see that now it's changed. Also, you can rearrange the index. You can just give like, in order to have like from 0, 1, 2, 3, I changed it from 0 to 4. And you can see that it's changed 0 to 4, 6. So this is also like, you can also rename. I rename the columns, the continent as now like the short form, population as POP, and surface area as SA. You can see you can also rename the names, and you can give different indices, and there's a lot of stuffs you can do with this. So this is, I just want to show a rough idea, but now I will go for an actual data. So it will be, I think, more clear, and you can understand the power of this pandas to do the lot of stuff. So is it fine now? Okay. Okay, now we are going to work with actual data. Because it's very difficult for me to create a random thing, right? So it's better to then go to some sites and get some data because they have large data sets. So I have like given some website called Kaggle. So you have to just log in, and you can see that there is different data sets, and I went for this all data set, and you can see different data are here. So in this, I have taken the data customer shopping trends data set. I went this, and then I actually downloaded the data. You can see the data is there, you can download. So from this, I got this data. So I have sent this data to all of you, and you have to, I mentioned like if you want all the things, you have to mount the contents like the Google Drive. So I think already mine is like mounted, but it's already mounted. But if you didn't, you have to just make sure all the contents from the Google Drive is mounted into Google Colab. And then now you see, I just defined the path because this data is stored in, you see this is in my Colab notebook, and there is a folder called data, and in this data I have lot of data, and you can see the shopping trends data is inside this folder. So what I need to do, I have to then change my path. os.change directory, you can see Colab notebook /data. So it's in the data folder. Now, if you want to read the CSV file, you have to go for pd.read. So mine is CSV. You can see that it's a CSV file. So you have to do underscore CSV. If it is an Excel file, so I'm just showing one example with the CSV. If it is an Excel file, you can do underscore Excel. So this is my file, so you load it. So similarly, you have to download and you can upload in your drive and you have to specify. Okay, sorry, maybe I just loaded this once again. Sometimes it takes some time to, okay, yeah. So sometimes it's a little bit slow. Now you can see that it's already reading. So you have to just give your path name where your file is there. So you can then get your data. So now you want to see what is that data, right? So you can do print df or you can just do df and you can see this is the data. So it's a big data. They have like customer, it's a shopping data. So it's kind of data of shopping, like they have customer ID, they have age of all the customers, like the gender, whatever item purchased, category, purchase amount, location. So if you see that, it is a 3,900 rows and 18 columns. So it's a very big data, right? So it's very difficult for us to check that. If I ask you, how many male customers are there? Like how many, lot of male, female. So if I ask you, it's very difficult, right? Like to go for each of the values. So we can see how we can do all this kind of stuff. Another thing I wanted to tell you that if I load the file, you can see that I just got pd.read CSV, right? Only like this, the name. But if your file doesn't have a headline, that means if you see here, like I have a customer ID, age, gender, item purchase, this is the headline. If you doesn't have a headline like this, if you go for the reading, like it will consider the first line as a headline. So it automatically defines first as a headline. So if you don't have a headline in your data, you should mention the shopping trends.updated CSV, comma, header is equal to none. If you didn't define this, they will automatically think that the first row is considered as the column name. So just make sure if you have some data, if it doesn't have a headline or header, column names, you just put header is equal to none. Okay, now we can, if you want to get some few rows, you can do just df.head. So you can now get few, because it's very difficult to see all the rows at a stretch. So you can just define df.head. So you can get first couple of lines. But if you want to see more, so you can just specify df.head of 10. So you can get number of rows from the top. You see, you have like 10 values, that is from 0 to 9. If you want to see the bottom values, you can do df.tail. So it's like first few lines, but if you want to specify, I just want to see only like 3 rows from the bottom. So you can just do df.tail of 3. Okay, now we already know that it is around 3,900 rows and columns, but you can just do df.shape. So they will show you how many rows, how many columns. Now, if you want to get the information, so let's see what this information means, information of this data. You see, like you can get all the information at a glance. That means you have all the column values. You can see like it's from customer ID, age, gender, item purchased, and you can see that non-null. That means there is none of the values, any of the column have no NaN. That means all is like valid numbers. This data doesn't have any vacant space. And you can also see like the D type. So the customer ID, age, these are integers. The gender, item purchase, these are objects. And you can see the review rating is float. So now you're familiar with all these things, right? What is integers and what is float. And the gender is like male or female. So this is considered as an object. So also you can just put df.d types. We already know that will also specify you what is the type. This is also give you all the informations, and you can see here how many rows. You can see that 3,900 entries and the number of columns is 18, and you can see that the memory usage of this file. So you can get all this from the info. And if you type df.dtype, you can get the types, like as I mentioned before, like customer ID, age is integers, and all these things is like float, object kind of thing. So if you do df.value counts, that means it will count how many. Because if you see this, maybe it's difficult for you to count. So if you do dot value counts, what it is means you can easily get how many integers, how many float, how many. So the object is 13. So if you have 13 kind of objects and integers is 4. See, customer ID, age, and then another integer is purchase amount is an integer, and the previous purchases are also an integer. So you'll get dot value counts gives the how many counts is there. Then if you want to know the statistics, you can do df.describe. So this will give you, you see, count, mean, standard deviation, minimum, all these things for each of the column. So if we see the customer ID, they are giving the count. So total 3,900. So we know that total 3,900 rows. So all the customer ID, if they counted, it's 3,900. So this is like mean of the customer ID. So customer ID is like 0, 1, 2. So that doesn't make much sense. But we can go for the age. If you see all the count, it's like 3,900. Because this is counting how many rows basically. And if you see the mean age of all the customers is 44. That means it is ranging from maybe 20 till maybe 80 or something. So the mean is like around 40 or maybe 70, 60. So it's a mean, like all the sum divided by number of. And this is the standard deviation. That means how much the mean value is differed. And this is minimum. That means minimum age. So if you see for all these data, the minimum age of the customer is 80. And the maximum age of the customer is 70. So you don't have to go through all the rows, right? So you can easily get from what is the minimum age of the customer, maximum age. Also, you can see that the minimum amount of purchase has done is 20 USD, maximum is 100 USD, and you can get all these details. But if you see here, all these details is only for integers, right? So because it's count, mean, standard deviation, so it's all the statistics is only for the numerical types. We cannot say anything for the gender, right? It's a male or female. We cannot say the average or mean, right? So this is basically for the numerical type. I mentioned maybe transpose. Transpose is like you can read this in column and rows in the other way. I mean, now you can see that this like a row becomes column, column becomes row. So you can read it in another, it's a transpose way. So if you want to see is there any null values, so I'm saying like how many null values is there. That's why dot doing some sum. And you can see it's all 0. That means there is no null value. So we have all values in all the section. If you want to get the column values, you can just do df.column values. So you can see 18. We said 18 columns, right? So it's customer ID, age, gender. So if you want to know that, you can just do df.columns.values. So if you want a particular column, you can just do df of gender. So you can see, right? It's 3,900 rows, like you can see that particular column. But it's like, male, female. So we don't get much information. So we wanted to do how many. So you have to do dot value counts. So if I see, maybe I can just do both of them. Okay, so because if you have two of them, it will show the last one only. So you wanted to see the value counts of gender, right? Sorry. You see, so how many male? Male is 2,652 customers and the female is 1,242. So if you sum this, it will be the total rows, right? 3,900. So similarly, if you want to see, there is location. You can see there is a location in the data. Okay, maybe I can just, it's difficult to scroll down up. So I can just put the data df. You see there is kind of a location. So different, like it's some regions in US, Rhode Island, Oregon kind of thing. So if we want to see the location count, so then if you do like location.value counts, you can see that. So lot of customers, like how many customers from the California, like 95 customers from California. And if you see like from the Texas, 77 customers. So if you dot location, that particular column dot value counts, it will, categorize into how many locations and how many counts. Okay. So then I just made a small program. If you want to see for all the column values, I mean, like if you see, I'm defining a cat calls as df.column.values, because like df of kind of a location dot value count. So I wanted this to be a general, because I want all the columns. So I just put df dot column values, df dot columns dot values, and you can just df.column.values, basically all column values. And for I in cat column, so I'm defining a variable, and that is going for m is equal to df of I, because earlier I was given here particular column, right, gender. If I want to see how many male and female, I dot df of gender dot value counts. Now I just given a integer I, so it is going for all column values. And if I print this, oh sorry, you can see that it's a, so first one I'm printing all the columns. So you can see the first one is like customer ID. Okay. The second one is basically the age. So it's showing like the 69 age is like 88 people, 57 age is 87 people, and then you can see that the gender, male is 2652, female is like this, and this is their item purchase. Blouse is purchased 171 customers, jewelry is purchased 171. So you can see that all that counts like this. So yeah, it's a large data. And if you want only the numeric, like this contains all the kind of thing, right? Male, female, all these things. If you want only the object, you can just specify like dot object, and you will get, you don't get like the age and all, only get objects. I mean like the size, you can get the location, all these kind of objects, and how many counts is there. Yeah, similarly, I just mentioned in the data frame, we can rename index and we can do lot of stuff. So similarly, you can do the index. You can change like the 0 become Alice, and first index become Bob, and second index Mary. And you can see that, like maybe I just put, it's easy to read from DF2. You see the first three indices, I changed only the first three indices to Alice, Bob, and Mary. So you can see that you can change the index also. Then it is easy, right? So if you have like maybe it's a large area, so you can maybe define some programs such that you can give all the names. Maybe you can say AB8 to Z, but it's 3,900. So I cannot maybe have to think how to change all the customers' name also. So then it is easy. You can say that what is the age of Alice, or what purchases she did. So you can just mention by Alice, because rather than like 0, 1, 2. So it's better to give some indices for the data to give better understanding. So just for an example, I just given 0, 1, 2, changed it to Alice, Bob, and Mary. So you can just see that if I want to know the information about Alice, I can just do .log. So this is just .log of Alice. So you'll get all the values of Alice. What is its customer ID? What is her age? Also, but it's like male. I just given Alice. As the gender is male, item purchased is blouse, and you get all the things. Another way is like you can do ilog. I mentioned this also. You can just specify the same thing, the first customer using ilog of 0. Similarly, you can do, like I mentioned, like you can just get only one column using df.gender. Another way is df of gender. Also, you can do df.gender. Both ways will work. You can also get from, I want from 0 to 10 values. you can just do 0. This is starting index till ending index, and you can get 0 to 10 values. So I'm not going for all these things. You can just check. So iLoc also the same way. So can you just see that what is this? This means I'm going for allocating 0 to 5 rows, and I just want only, because if you have a comma, I mentioned like you have a row and then you have a column. So this is like you are getting like two indices, like first one is for row and column. So you have like 0 to 5 row and you want only the information of the age. So you will get like this. So you have like 5 rows and you get the age of the people. If you want multiple things, you can just give age, comma, gender. Yeah, sorry. df dot, okay. Okay, sorry. This is like, I was like resetting. So if you go for df.log 0 to 5, comma, age or gender, you can just get from 0 to 5. Yeah, you can see get from 0 to 5 the age as well as the gender. Another way you can do df of this value. I mean, you're considering the first the column and then the column, and this is kind of 0 to 5 is kind of rows. This is another way. Yeah, like this is basically the item purchase is showing. So this is like 0 to 10 row and the fifth column. So if you can do, like, you can access this. So this is the how the way you can access each of the row and how many columns you wanted. Like you can try this in home. And the another one is like group by function. This helps to categorize the data. That means I'm just want to show you the data again. So this is our DF data. And if you okay, so if you have a df1, I just defined it as df.groupby of category.count. So if you have a group by function, so your index will be the category. You know, like earlier it was 0, 1, 2, it becomes now category, and you can see dot count. So you get all the things will be coming in front of category. So if you have like accessories, clothing, footwear, and you can see the customer ID, how many customers, like it's your going for count. So you wanted to see how many total accessories, how many, like this is the age of the total, like, I mean, this is basically doing all count, but this doesn't give you much information. But you, if you want to categorize with the based on the category, you can just do like this df.group by category.count. And if you see this is we are grouping by age dot sum. So if you look at this, yeah, what we are doing is we are looking for each age. So because we are categories based on the age, so this index will be all age, and you're summing all the customer ID. So there is a lot of customers ID. So the 18 age, whatever the people have the age 18, so you're adding all the customer ID, all the purchase amount adding. So in this data, you have lot of 18-year people, all the people's purchased amount you added, and the review rating and the previous purchases. So you'll get some idea of which age group like, you know, did the most purchase or something you can get from this value. So if you want like only one particular column, because this has lot of columns, right? But if you want only particular column, you can just take the purchase amount. This is one particular column and the age, and this is giving the purchase amount. The other thing is you can do the Boolean function. You want to know how many people whose age is greater than 30. So you can do df of age because you're selecting particular column which is greater than 30. So you know that you will get this is like true or false. Yeah, this is basically Boolean condition. So you want to only because I'm changing df age is df of that condition. So if I print this value, I get only from the data, I get only the data which is having the age greater than 30. You see the customer ID is first, it is having age greater than 30. The customer ID 3 having age greater than 30. And you can see that how many, like from this it's easy, how many people have like age greater than 30. That means 2,951 people have age greater than 30. So this is like age greater than or equal to 969. You can get how many? Like it's like 155 people. You see, like it's like 155 people have age greater than 69. Also, you can want to see that how many people, like what all, how many male customers, and like you can define df.gender equals male, and you can see that 2,651 and all these customers are like males. Similarly, you can find for females, and you can have multiple condition because you want to find the category to be footwear and at the same time the gender is male. So you want a data set having all the male customers which buy footwear. So if you have this condition, if you see, you have like all the male customers and you can see the category they bought is footwear, right? So all the male customers footwear. So it's like around 400. So the 400 male customers bought footwear. So that is the information you will get it from this. Okay, so also you can do changes to your data frame. That means you want, like the data is like a random, right? If you see, you have like maybe if you see your data, it's like first customer is like 55, next is 70, but you want all data to be, from the ascending order, from the lower value to higher value. So you can just do like the sort option. So I just define a new name df8. This is like by age, ascending is equal to true. That means it's going from lower age to higher age. So if you do like, if you see this, you see the first customer, like now the customer is like based on the age 18 to 70. Also, you can do the other way around. Ascending is equal to false. Then that is like from 70 to the minimum age. Also, you have like multiple conditions. Item purchased, category, like ascending or descending, you can get that. If you want to drop some rows or columns, like you can do just df.drop of 2. That means you are dropping that particular row. So here I'm giving df.drop of 2, 5, 2, 5. That means I'm dropping second index. So you see 0 first, and I'm dropping second index, and also I'm dropping fifth index. So you can drop the thing. Also, you can drop the column df.drop. You can, I'm dropping the columns like age and gender. So you see, it was originally 18 column. Now you have only 16 column, and you can see the age is not here and the gender is not here. So you can remove those data. If you want like particular, you don't need this much 18 columns. So you can just choose, I want only age, previous purchase and purchase amount. You can then just choose only those, you see. So you can do all sort of things, whatever things you wanted to look, you can just get it from here. Also, you can add new series or you can modify the data because I just finding a new series like this, 1005, like if you see. So I just added age is 10 and previous purchases is 100 and purchase amount is 5. And then what I'm doing is I am adding plus new series. So here I have like age, previous purchase and purchase amount. Here also I defined the age, previous purchase amount, and I'm adding. So if you want to add something, you want to have the same number of like columns. Also, you have to have the same number of column names. So that's why I just define age, previous purchase, purchase amount. And if I add this, you can see that previously we have like age, previous purchase, like you can see age is 55, previous purchase is 14, and this is 53. Now I added these series and now it changes to 65, 114 and 58. So similarly, you can do a lot of modifications. You can also modify the data. That means you can add a new column. So I'm defining a shopping as this series, Sunday, Monday, Saturday, and in this 0, 1, 2. And I'm adding this like df of shopping day is equal to shopping because this is a new column and that column is named as shopping. This is this series. So if I add this to my data frame, yeah, it's some things. They're taking some time. Okay, now you can see it's 19 column, right? So because you added one more row. Yeah, so like you added one more row like shopping and you can see that it is at the end. But you added only 3 values, right? Sunday, Monday, Saturday, and you can see the rest of the values, they will show in name because you didn't give the values, right? So you just added the values. Yeah, it's getting a little slower. So you can add the column like that. Also, like you can, I don't want that actually that data, so I can just drop. So you can do df is equal to df drop dot drop that column. So we can drop the shopping day. Okay, so it's not found. Maybe the name is okay. You see the name I have given is capital, it's small letter. So here it is shopping days like I'm changing shopping days Monday. So earlier it was like Monday, Sunday like that. Now here I'm giving adding a new column like this, but it's all like value is Monday. So if you see here, you can see now it's like basically 20 column because there is one column I already added initially. It is like Sunday, Monday, Saturday, and now it's like a shopping day. All values are Monday. So if you want to drop, you can just give like this. You can drop the column shopping day. Yeah, so it is already removed. And if you now, if you just type now df, like if you go for, it's a little bit getting slow, my computer. So if you check df, what is the df now? So that column will be removed. And skipped. Okay. Sometimes, like if I work too much, it will get. Okay. Okay. If I do for df, you can see it's now 19 column because I removed one of the shopping day. If you want to remove this shopping day also, you can do again like a df dot drop. Another thing is you can rename the column indexes like item purchase becomes like this. I showed you earlier. So also you can do another like now I define a new column like df of total expenses that becomes df of previous purchases into df of purchase amount. So you can create a new column with the like multiplication of another 2 columns, give a new column. So if you want to see the total purchases, you see I added a total expenses, so that will be some multiplication of other 2 columns. So you can do all kind of stuffs using this. Okay, I will just quickly go through this, and you can also do some statistical info. As I mentioned, like you can, I'm just defining purchase amount as df of purchase and age as df of age. And I wanted to see that minimum and maximum. We already see this in the describe, what is the minimum maximum, but you can see the 20 is the minimum purchase amount and the maximum is 100, and the age also minimum is 18 and maximum is 70, because we already got this information from df.describe, but you can do all this kind of stuff. Then I just want to know that because we modified some, if you modified your data or something, you can just save that into df2. We have to save it as a CSV, and you can just give the modified name, modified shopping.csv. And if you do that, it will get saved and it will be saved in your drive. So if I check my drive, so it will be in here, Colab notebook. Yeah, it will take some time, I mean, to get. So basically, okay, I changed my drive into this data, so it should be in this folder, if I see. Okay. So it's like this was the data I used, shopping modified, and you can see now it's like modified shopping.csv. It appeared in my Google Drive. So this is how you can save the data. So this is kind of thing I wanted to show you, how you can get the data from outside and you can do a lot of stuffs. You can find how many customers is greater than particular age, or which kind of category, how many people were from one location, and you can do all sort of stuff. So I just want to pause like for 5 minutes to, if you are fine with this. And the next one I wanted to show you is visualizing these data using Matplotlib. Then it is more easy for to analyze. More than going for these data. If you can visually see them, it is very easy for you to analyze. So I can just pause for 5 minutes and ask you if you have any doubt. So I already sent this like module 2 also. In this, I will just maybe quickly tell you, you can also work by your own, but I just want to, because I don't have much time. So I can just give you a very brief introduction, and from the next session, Dylan will be talking more about this. So it will be more clearer for you. So for the data visualization, I told you we need data visualization to analyze the data easily and to understand, and if you have certain patterns. So basically most popular in Python is Matplotlib, that is Matplot library. And there is another one called Seaborn. So that is also very easy to use. So I'm just, because I opened a new section, I need to import all these libraries. So I'm just importing Matplotlib and NumPy and Pandas, because all these things is also needed for this, for the plotting. And so if you want to know about more about Matplotlib and how to use, you have this kind of documentation, you can go for plot types. You have different examples, basic plots, scatter, bar plots. You have lot of examples, and you can check bar diagram, how to do these things, and you can go and you can, if you have any doubt, you can check here. So my aim is just want to introduce you to this, but you have lot of steps in the internet and you can check how to do this. So basically, if you want to do any plots, what you want? You want X and Y values. So I'm defining X is one list and Y is another list. And it's simple, we are defining Matplotlib as PLT because we are importing it as PLT. So we will plot plt.plot X comma Y, and you can just show what it is. This is basically the plot. But also you can adjust the size using, there is a plt.figure fixed size. That means this is the 4x4 means what is in this x-axis, how much is the length, and y is. So if I change this into some 10, you can get a structured pattern. So you can change the figure like that. If you see, this is a just graph, but you always need what is X value, what is Y value, how to give the title. And you can see that you can give X, Y, and plot. And you can give the X label, Y label, title as like this. So if you do like this, you can get X, Y, and title. And I also mentioned here, you can try this, you can change this line into a different shape. If you want there is a scatter, or if you want a dashed line, you can just change it into this form. Maybe I will comment out this. like plot and XY. I wanted to change this into a color green. I wanted to change a different line style, line width. And if you plot this, you see, you can change it. So you can do a lot of stuff. You can like check the library and you can work on it. And another thing is like, okay, this is also showing the same thing. And another thing is if you have multiple datas, so here I have defined X and I have two values. Y data is a data and I'm plotting this. So I need to give this is called a legends, because if you have more data you want, what is this orange line, what is this green line. So for that you have to give like plt.legend, and within a curved bracket you have to give what is this. I'm just giving the name as Y data is a data, so you can get. So this is a basic idea of the graph, but there is different kind of graph like bar chart. There is like histograms. So maybe I don't have time to go through all these things, but you can just check. So bar diagram is something like this. So you have like Alice, Bob, Mary, and I have a white dot. So if you want different chart, it will be plt.bar. That means it is a bar chart. Similarly, you have like some histograms. Histograms is basically a distribution. So if you have some kind of values, how many, like this is kind of a random like 50 numbers from 0.28 and 0.58. So this each random values, like you can see that how it is distributed. So you can see that some 0 to 0.2, the value is like, the around 4 counts of numbers is around this value. So this is basically like the counts versus like how these numbers is arranged. That is basically histogram. You can also have pie chart. So the advantage of pie chart is you can get a proportion, I mean percentage. So if you have different values, you can see that how much it is, proportion, how much. If you see these 3, 12, 5, 18, you can see that 12 is the maximum value. That is B, you can see here. So if you see that how much percentage it is from the rest. So if you give here auto PCT, that means auto percentage. So if you just give auto PCT, it will automatically find the percentage. The percentage means like 12 out of the whole things into 100. So it automatically calculate, and you can see that around 42% of this value is covered by 12. So the pie chart is useful for that. So there is also another thing is Seaborn. This is also helping for visualization. And so for this, it requires sometimes less number of code to define things. So you can also, I just provided the guide here. So you can also check this Seaborn. Also, there is a tutorial and you can see that how many like different kind of plots and how you can display, you can check it out. So I just want to show you some examples of our shopping data, because we just familiar with some of the values and all from the data. So I am just already imported, but just importing all these libraries, and I am like mounting the contents, because it's actually a different file, right? So I have to again mount all the datas, because you have to link with your Google account. You have to give access. Okay, so it's like loading. So it's mounted. So all my contents from the drive is mounted. So I'm now going, because I need the data, right? Our DF data. So it's in this directory. So I change the directory, and I'm like reading my data, DF, because we need the data, right? So we got the same data. Okay, now we from earlier calculation, we see that how many males and how many females in this category, but we can do it like plot wise. So if you see df gender dot value counts, we discussed earlier, we can get how many males and females, right? So we can do this is like in a plot wise. So one way is like we have this count, so we need x and y. So we are renaming this axis as gender and the index as counts, because if you do like this, you can get like gender and counts in this format, and then it is easy for plotting. So if you see, I'm first defining a figure like a size 5, 3, and my y is basically DFGEN is basically now this thing. So from this data, actually, from this data, what I wanted to do in the y is basically counts. So dfgen dot counts, and x is basically dfgen dot gender. And I'm defining the bar colors is like blue and orange because I'm going for a plt dot bar plot. So I'm defining two different colors, and I'm giving title, x label, y label. So if I see like this, I'm getting like this. Number of customers, like I can see the male, how many, the female. So this is basically bar plot. You can see that I'm giving the colors, but I'm just plotting it as X, Y, and only the width. I can change this width, like if I say 4.5, you can see the width is reduced. The other thing, I define the colors, because if you see here, the colors, both colors are same. But if you want to show your graph to some people, like, if it more visually distinguishable, I'm just giving like including the colors. As you see, I'm just giving a color is bar colors. The bar colors means one tab is blue and other is orange. So if I do this, you can see like with the two different distinct colors. If you want to change this into horizontal way, you can just do bar H. That means you are going this bar in the horizontal way. So you can check it this way. Now it becomes horizontal. So you can do different way to, modify your graph. And another one I mentioned about SNS. If you're using SNS, it's very easy. I mean, you can just do SNS.count plot because we need the counts, right? How many gender. So just give X is equal to gender, and what we need is the data is equal to DF, because the data has to be taken from this DF, and what you want is gender, and what you want is count. So the width also you can give, and you don't need to give X label, Y label, because all these things are already into this SNS. Because if you see, give this, automatically the X title, Y title is comes, because the gender is the x-axis and basically it's count, so it automatically counts. It will come. Only the title doesn't come, so you have to give the title. But if you give like the title and X label, Y label, it will give a different one. If I see, this is like if I'm giving the label as number of customers, you can change it basically. So now it becomes number of customers. So if you want, you can give the labels, but if you didn't give also, automatically it will show you. I just want to see, you want to see the proportion, right? So for that, it is easy to use the pi. So you can use plt.pi. The y is basically, you can see we already defined y. That's why I'm not defining it, because we already defined y is the counts. So, and the labels is the X. And if auto PCT, you can get this as like pie chart. You can like easily see. You can see from this 68% is basically male. The other one, like you are just giving the value, right? So you have to just actually do the math to find how much percentage. But if you're using pie chart, just do this auto PCT, then you will get 68% male and 32% female. There is something like explode. You can just try. You can change the form of this pie chart, maybe to make it a 3D kind of effect, and all. You can do this. You can do a lot of stuffs, like if you check in the internet. Also, just want to see the distribution of the customer age, because we have lot of 18 to 70, right? So overall distribution of the customer age. So I'm using a hist plot. So you can do plt.hist df of like age, that because you're using age, and you can define how many bins you want in the histogram, and you can see. You see, now you can understand that from around 18 to 20 age group, you have more than 200 customers. You can see that the minimum is around maybe 60, maybe this is like a 65, or like within this range we have like minimum customers, like around 100 or 50. So this is kind of distribution of the age. Similarly, you can use like category distribution as dot count plot. Now if I do category and like number of counts, then I can see that we have different category, clothing, footwear. So if you see in the data, you have like these 4 main categories, and you can see that for the clothing, you have like around 1,700 something like counts people bought, footwear this much, and outerwear. So you can now get more idea, right? Rather than like checking from the numbers, if you have a plot, you have more visualization of the data. So this is what basically data analysis do. They have a lot of big data, and they just wanted to see what information I wanted to get from that. So they will do based on that. So distribution of category based on gender. So I just want to now know that even in the clothing, how many male people, how many male people have the clothing, how many female people have the clothing. For that, I can use X is equal to gender and Q is equal to, Q is kind of a parameter. I can just show you and see how it is. So if you see, the hue is the one which comes out here. That means X is the gender. So they're basically showing 2 genders, like the male and female, and hue is mainly you give the category. So we have 4 categories, right? So it shows like that. This is like basically clothing, this is footwear, outerwear, and accessories. So you see, you don't have to give that, okay, it's a name is clothing, name is full. You don't have to label the name. It all automatically comes. So that's why SNS is like very easy to do this. If you change this as category, and if I just give this as category, category, and if this is I'm giving as gender, you can see. Now you see here it is comes as gender. So now it's like the X is basically category. So you can see the clothing. So this is like male, this is female. So you can do in different way. So also you can check. So I wanted to show you. You can like check because I don't have like time to go through all. You can check this is different kind of, purchase based on season and payment method. Maybe I can just run it. This is based on different season and the payment method. You can see that like X is basically season. So winter season, spring, summer season, and I just want the Y as the purchase amount. So this is basically purchase amount, and hue as payment. So if you see hue is there, so that will give all the kind of thing. It's here. It's a basically payment method. So you can see the different season, what is different payment methods, and how much like, the amount paid for different method. Then this is something like distribution of item purchased. That means like we have like blouse, sweater, jeans, and all these things. Like you can see the how many count of that, and you can do a lot of stuffs in this. So I don't have time much, right? So it's kind of almost over, right? So I think you people can work out this, like, you just want to run these things, and you can change the values, and you can then understand how it is has been done. So one more thing I just want to show you is like there is a subplot. That means you can have all the plots in the same, like you can have different layouts of the plots. This is basically called subplot. You can do this like, you can just define plt dot subplot 2 comma 2 comma 1. That means you have 2 rows and 2 columns. So the total you have like you can include 4 like subplots, and the first one is like information regarding the first subplot. So I'm giving sns.count plots gender data in the first. So you can do plt.subplot. So you have second data, and you can give the data of that 2 comma 2 comma 3. That means information about the third, and then this is information about the fourth. And you can save also plt dot, you can do save figure, and you can give the name, and then it will be saved in your Google Drive. So if I check here, yeah, it's a little bit safe. Like you can use like your using the dot save figure. You can basically save your figure in the drive. So I cannot, I don't have time to go through all these things, but I think it's, you have the script, so you can check the script and see how these graphs. So from this, I just wanted to tell you like how important this pandas to analyze the big data, and you can use this matplotlib to visualize the data and to get information. So that's all. I just want to talk about this introduction to data analysis course. You can maybe submit. If you see, if you have some assignments like this, and I don't know, it's okay. I can open now. Okay. Okay, so like we covered this, like you can see in the number, I have given some matrices and you can choose the elements of the matrices. So we covered this, and you can do all this by Boolean matrix, like how the sum of the columns and how many numbers is divisible by 3 in the matrix. You can use the Boolean algebra. And this is exercise for the panda. So I have given some data, and you can do add column names, add index names. So you can check my script, and you can like answer these questions. And if you have doubt, you can also check in the internet. And if I think the book is also helpful, you can refer the book also to get the answers. So once you do the answer, so I told you you have to prepare your like once I send you the script, don't edit on this. Take a copy of this, and once you did your answers, you can just do file. You can download. So download as like .ipynb, that is like a Python file. You can download this with your name, like you can change the name as your name, and you can download this file, and then you can send it to the organizers, and maybe they will send it to us. Because otherwise, if you want to share all these scripts, it's difficult. So because I can load this into my Jupyter notebook, so you just after finish your assignment, you can just download as IPNB, and you can just send that file. Then I can just check, and I can try to give some feedback. But at the end, maybe I can also send the answers to you. Maybe not now, but maybe after 2 weeks or something, I can prepare the answers and send it to you. So you can just check also. So I think it's time is over.